So, hello everyone. So today is part 2 of what we have started previous week about Matryoshka Embedding Models. Today I am going to show how I trained Matryoshka models for Arabic sentence similarity as part of my project, and I am going to do a quick overview on how we translated the dataset and how we do the Matryoshka representation learning. So we have covered in part 1 about some overview of embeddings, and we made a motivation for next step, which is Matryoshka, and we learned about how they store important information in your dimensions, how they allow for truncation without significant performance loss, and how we can train this Matryoshka embeddings models. So first step in my project is to translate the data for Arabic sentence similarity, and actually the source of these data sets are from the Stanford Natural Language Inference called SNLI, and also multi-NLI dataset, and they are available on Hugging Face, of course, in English language. So they are like benchmarks for evaluating these models for NLI tasks, and also we are using it for various NLP task, providing pair of sentences with their labels, class or score or whatever, and we're using it for semantic relationships. For Arabic, we try to translate the datasets, and also we have focused on four different subsets, like the pair one, which is contained the anchor and the positive, as you can see in this example, and we have translated 300k of training pairs along with validation and test. And we can say that pair subset are recognize and quantify semantic similarity between the sentences, and we can do question detection, duplicate question detection, or paraphrase identification. Okay, so next we have done the triplet subset, and which is contained of anchor, positive, and negative, and they are much larger than the pair one with 500k. Also with the validation and test, and also we use this data set, and this is actually the main data set I have used for training the Matryoshka embeddings, as we're gonna see. So this model learns to push similar sentences closer and push the dissimilar sentences apart in the embedding space. Then also we have considered the pair class and the pair score, and the difference between them is in the pair class we are doing the label 102, and as you can see here, the different classification of these relationships between the sentences, and it is really big data set here. It's near 1 million, so it's really very useful data set. We can use it like a rich resource for training these models to understand and reason about semantic content. Same as for the pair score, instead just we're giving similarity from 0 to 1, and we also using it for assign the similarity scores between two sentence pairs. So yes, also as part of my evaluation for the training of the Matryoshka models, I have translated also a popular data set called semantic textual similarity benchmark, and also to provide the scores between 0 to 1, and these are the training or the dataset details. So yes, as part of my data processing, and here I am going just to explain it very fast, because you're gonna see all the details in a very soon published paper, hopefully. So we done tokenization, so we can tokenize the text to individual words or subwords and prepare it for the translation from English to Arabic. Do some steps related for the neural machine translation, OpenNMT. So we need to do some normalization steps, doing some pre-processing and the cleaning of the data, and then we structure the data as we saw here. We have sentence to score. Here we have different columns. Here anchor, positive, negative. So we need to structure the data so we can, after translation, we can quickly like do the processing or saving it in CSV or JSON format. So yes, this is pretty much the data pre-processing steps. And then moving to translation process, we have used like C Translate 2 model for which is a OpenMT machine translation model, and it is very efficient. So we are using it. The dataset are uploaded in Hugging Face, of course, and then we just load it. And then we use the model along with the tokenization using sentence space, and then we do some configuration by setting the language specifications and doing like of course the handling the special tokens and everything. So as a result we have like high quality Arabic versions of the SNLI and multi-NLI dataset, and I can tell this the first translated SNLI multi-NLI datasets. So no, as my knowledge, no any previous work done. So this is the data summary, and you can find it public on Hugging Face. So if you go on my space here, and you can see the data sets, and of course I have published this before, so you might see some people are starting downloading it and using it. So yes, now for training the Matryoshka learning, for my investigation actually, I have or my objective was to train and evaluate several Matryoshka embedding model using this Arabic NLI triplet datasets. So I chose like an English sentence transform model called Infinite Base, which is trained on the English triplet, and I use it like just to assess the cross-language transfer capabilities. Then I have used multi-language sentence transform models, the paraphrase multi-language MPNet base, and also for the other one, I have used Labas for like which is like paired sentence embedding. So yes, I also have used like Arabic sentence transform model like Arapaired and Mapaired. We have, I know we have like many of options that we can use for assessing all these sentence transform and others. But for my work here, I just wanted to see the multilingual with the Arabic and just one English model to see the performance and the ability to like do cross-language transfer learning. So yes, our goal, yeah, is to have like one sentence in Arabic, doing like the Matryoshka embedding model, and then we can use whatever dimensions we want based on our resources and our targets regarding like the computational resources, the performance, the speed, and more. So this is the process pretty much from the original paper of Matryoshka representation learning. We do like having all these data on Hugging Face, so we are loading them, and also we have the data set, we load them, and then we do like some configuration. We have the similarity function is cosine similarity, and we have to set like the maximum sequence length, and then along with the batch size, of course. So we have chosen like these dimensions. So the each model can be represented by these output dimensions and enabling the model to produce embeddings at various levels. Okay, so we done also optimization using like loss function, which is called multiple negative ranking loss, and Matryoshka loss to train these embeddings on multiple dimension. Okay, we have performed like them as I have told before. The evaluator is on the STS benchmark, and yeah, this is pretty much the steps that we have done. I just summarize in 10 steps. You can have a look, and of course everything will be in details on the paper soon. So yeah, all models are public, and again you can see the models here on my Hugging Face, and I am as I can tell, I see like people doing like are interested in this topic, and they start downloading these models and using for their projects. So yeah, you can access these models. So results, I have many results included in the paper analyzing everything, but as I can tell now that basically all the training Matryoshka embedding models have outperformed the base models for the malparts, for the RPERT, for the Labas and enemy base, and also for the English model. And the interesting thing is that the multilingual models are better than the Arabic ones. Also, in terms of the English one, we maintain like good performance actually using these embeddings. Yeah, so we have seen like increase in from 20 to 25% across all various similarity matrices, and here we can see like from different matrices and evaluation, we can tell that the paraphrase multilingual MPNet base have all outperformed other ones, except in some places we can see the labas come and like to have comparable results. So yeah, finally I would like to just say about this app called Arabic Sentence Similarity Application, and also it is available in Hugging Face, so we can directly go and we can like choosing sentences here along with the models that you want. If you want to compare two sentences, or you want to compare one sentence to other three, and also you can choose the dimensions since this is a Matryoshka embedding model, and then you can like just submit and see different results with the similarity score and also on word level for some models. Okay, so this is great. Yeah, this is pretty much for the presentation, and also I have prepared this quick network just to explain the idea of using the sentence transformer and the cosine similarity to compare sentences, or the semantic similarity between these sentences on different dimensions. So using sentence transformer, I'm just getting the model from the Hugging Face like this, and then I have like the dimension, and of course I can choose any one of this, and then I give like three sentences and do the encoding along with the dimension to shrink the embeddings dimensions. We can see here the cosine similarity, and of course when we run this, we can see the tensor with the similarity score. I have left like different examples we can try and see. So yeah, this is pretty much for the Matryoshka embedding models. I hope you have like an overview of how we train, how we use it, and yeah, everything will be in details in the paper hopefully soon. Thank you very much, and I hope you find this beneficial for you.